We'll recap consciousness here. Uh, it is the sum total of our sensory simulation, sensory consciousness, our thoughts, and our emotions. Traditionally, the fragments of consciousness are called qualia. A thought, which is a qualia is a thought, a sense, a feeling. But I've divided the fragments of consciousness into the sensory consciousness up here, and it's divided by this little line, which is this SI is you have your different types of senses going through up until that point, sight, sound, etc., hearing. But instead of calling these qualia, I call the fragments of these, I call them sensory information. So each of these little letters represents potential variables in consciousness, representing different sensory informations. There's the sound of a bell, the sound of a siren, and it notices or the brain, the mind, notices patterns in this consciousness, sensory consciousness. So the mind uses this sensory information, or SI, to create memories and retrieve them. So it uses this information to create memories. While the bottom half of consciousness is caused by retrieving memories. We retrieve image thoughts. We retrieve symbolic thoughts. And we retrieve emotions, reinforcing emotions and punishing emotions. And a set of algorithms operate on the information in sensory consciousness to retrieve and construct memories. Whoa. Jesus. That happened. Memories, okay, so we have these memories down here. Their function is to help us respond to sensory consciousness. They are created from consciousness. Something in our consciousness occurs, and we can transfer this information into memories. We can then retrieve these memories to respond to consciousness, and we could retrieve memories to think about sensory consciousness. So retrieving memories causes three main processes. Moving your body is caused by the retrieval of muscle memory or motor action memories. Thoughts are being caused by retrieving symbolic memories. Feelings are being caused by the retrieval of emotional memories. So the structure of memories. So you have a set of sensory data right here, a sensory packet, sensory representation packet, and it represents one or a group of systems of reality. So, for example, me, you have a sensory packet of information that represents me in your mind, so that when you see me, this sensory packet is used to recognize me. You have a memory of me, and then when you encounter me, you recognize me because of the sensory packet. So, since these packets, you have different types of these sensory packets. And since these sensory packets are based on reality, you have this sensory information which represents reality, and then we create memories from this representation into sensory packets. So since it's based on reality, they're divided based on reality. You have system sensory packets, like me or you. You have interactions. Sensory packets, like let's say me running, I'm dancing. You have state transformations, which are very much interlinked with dancing. You have, I guess, a better example of that is like dropping a ball and it hitting the ground, and that's an interaction. And then the state transformation is like what happens after that. So you have also specific sensory packets. Uh, so you and your family, or a tree, a specific tree in your yard. And then you have general sensory packets. So trees, you know that's a tree. There's all these different kinds of trees, and this big kind of group of general sensory packets that help you recognize not just necessarily specific tree, but trees in general. Function. So as I said, these sensory packets allow us to, the function of these is to allow us to interpret and respond to our sensory consciousness. So when we see our family, we feel love and affection because we have a sensory packet of information about them, and we have associated love to the sensory packet. Now, motor actions. Motor actions are right there, that MA. Hopefully you can see that. MA. These are memories retrieved to cause movement. They can be moving towards so they often move in response to the sensory packet. They can move like in a pursuit fashion or an avoidance fashion. Here you see a grizzly bear. You're probably going to go away from that, but if you see a little puppy or something, you might go towards it. Examples of retrieving motor actions to wrestle. And also, motor actions, I should really say motor actions / glandular actions, because it's also glandular actions such as salivation. Okay, we also have emotional memories. These motivate behaviors towards the sensory packet, the physical systems that their sensory packet represents, or symbols represent. So we have the emotional memories, and these dictate how we behave towards the sensory packet. So does the motor action. It's almost like a higher form of motor action. It's not just based like I see something, I do something towards it. It's like I see something, I feel something towards something. I see something, a dog, and it makes me feel a certain way, which makes me move a certain way. It's not so direct, where I just see like an ant seeing, or praying mantis seeing prey. It sees grasshopper, motor action, eat, catch and eat, catch and eat. There's no emotion, I wouldn't think. But these emotions and motor actions work in tandem, because there's certain motor actions that are associated with certain emotions. Okay, so types, for example. So we have types of emotional memories. We have love, which makes us more nurturing and protective behavior, that are motor actions that are associated with that emotion. Now you have hatred. Now they have more motor actions of destruction and aggressive behaviors. We have envy, which is more destructive motor actions. We have sexual emotions, which elicit sexual motor actions. We have disgust, which can go bad, I think, and sometimes good. So it's an avoidance behavior, but disgust can be good or bad depending on what sensory packet and what symbol we associate it to, and also if it's like a loving disgust or more like a hating disgust. So it's like I feel disgusted towards with violence towards women, but I got to be careful because it can lead me into like hatred and bitterment to the world and how much it does to it. It does this to women, but it's more like I need to just have the kind of gut-wrenching like nastiness, but not like but not let it get. It's almost like sad instead of get to hatred. Then it can become something bad and toxic. So, and it depends on what you're disgusted with. You can't be disgusted by so much people, but like actions and interactions that you don't want to see. So, if we're just disgusted by people and avoid them, that's bad. But being grossed out by unhealthy foods or unhealthy behaviors is these kind of sad behaviors is a pretty good thing, because it is a pretty good thing because it helps us avoid them. Symbol label. So we have this symbolic label right here. This is in the later stages in the evolutionary development of the mind, it can create symbolic labels which represent the sensory packet. It allows us to talk about it and stuff. So we have types. We have the different ones based on the different aspects of reality. System labels, interactions labels, state transformations labels. We have general labels and specific labels. Symbols. So, example, Justin, book, and even non-human language. Bonobos have symbolic language that they use. Functions. Yes, functions. So, it allows us to communicate the sensory packets to other minds, and in later human societies allows us to inquire about them, to build knowledge of them. So we're not just seeing, we're not just, dog. Let's say we're a dog here. We see our human. We have a sensory packet of our human pets. Because we're a dog, and we have emotion of love, and then we just wag our tails, And we may have a little bit of a symbol, but it doesn't really go beyond that. The dog, beautiful, and his companion, super healthy to have. It helps people, but they don't have they don't inquire deeply. They have consciousness input. They see human, you owner, sensory packet owner, emotion, love, motor action, wagtail. That's pretty much what's going on there. I mean, they can't inquire with symbols as to wonder what what who is. I love owner, but who is owner? They don't do that. It's just I love owner, wagtail. And it's great, but they don't have that higher symbolic thinking. So we evolve our memories. So there's mimetic evolution in this. Okay. We evolve our memories with our own cognition, but also by communicating them to others. This communication involves changing these internal memories into technology that can convey them via writing, and even spoken word can be considered technology that is used to transfer these memories to other people's. Spoken word could be considered a kind of temporary technology, because we're modifying the air. It's like how writing modifies pages or tablets, except it's temporary and quickly collapses. So, mimetic evolution involves not just thinking about your own memories, but transferring them into technology, which can be transferred to another mind, which can then think about them. This kind of cultural technology, transforming them into cultural technology. It's words, spoken words, and written words. Now we have a belief network. This is what this whole thing is. So generally, this is kind of what animals have. I mean, they may have a little bit of symbol, but it doesn't go too much beyond that. And this is more of like a person's memory system. So, belief network. I've discussed the symbol, question, answer, premise structure of belief networks before. So, basically, you have this system right here, or this symbol. You have the sensory packet, let's say a tree. You have a symbol of a tree. And now you have questions about the tree, right? This is the questions. What's the past of the tree? What's the present of the tree? What's the future of the tree? You have these questions, and then you have an answer. You have an answer about its past, some sort of question about its past. You have an answer, and then you have a premise that supports this answer. Same thing with the present, and then future. Okay, this forms a belief network, where you have a network of beliefs that describe, explain the past, describe the current, present, and predict the future. You have a belief network that describes, explains, and predicts the symbol of the sensory packet. So whenever we try to debate, argue, or even do science, this, it seems, is what we are creating. We're creating these belief networks. There's an observation. So you have an observation up here. Then you have a sensory packet. Then you ask a question about it. Then you create an answer to this question. Then we create premises to support or falsify that answer. Function. The network, this belief network, explains, describes, and predicts information about sensory packets and symbols to help us make decisions towards them. How do I need to interact with the trees? What do I need to do with the trees? Do I need to cut them all down and burn them into paper? You know, what's going to happen in the future if we do that? You know, so, you know, and there's of course, you know, good cutting out dead growth. You know, cutting down trees isn't always a bad thing, of course, but you know, there's this belief network allows us to rationally interact with this symbol and the sensory packet, and thus really the symbol or the physical system that the sensory packet represents in the external environment. So you have this external environment up here, wherever, input, it goes into the input into this consciousness, which is right here. The input goes into this, and you know, goes in here. And this is all just about interacting with the stuff outside of it. But, yeah. Okay. Knowledge. So we have knowledge. Knowledge is truer symbols that have truer premises to support them. These symbolic memories more accurately represent that reality that's outside the mind. You know, it's reality outside the mind. This is all representing. This is making memories of. Free will. Free will from this perspective is, it's not, you know, it's such an archaic term. Kind of bugs me. People that is even used. Okay, it's more like there's retrieving memories to act. You know, we're not just freely willing ourselves into, you know, no. There's a physical system that is operating, that is the human. And this physical system and its operations are causing the physical system of the human to move. And what these operations entail for the mind is how it operates, is it's retrieving memories. So it's the retrieval of memories to act, free will. It's more like retrieval, memory retrieval. When you say free will, you mean when we say free will, we should say memory retrieval. So, and that's very much influenced by our genes and environment. It's a systemic process. The retrieval of memories is not free or positively determined. It's more like it's influence, meaning behavior is more and less probable to happen because of environmental and genetic conditions. So the retrieval of memories to cause behavior is probable, it's a probability. This thing is more probable. This behavior, this retrieval is more probable to happen or not probable to happen given these conditions. Operant and classical conditioning. I have constructed an algorithm that operates on consciousness and memory. And I'll go over each step. while describing the purpose and relating it to the examples of operant and classical conditioning. So classical conditioning. The mind notices when sensory information and consciousness matches to sensory packets. So the mind notices when information in this matches this. You have the sensory packet of dog, your dog, my dog, Tawny. Tawny right here. And when I see Tawny, my mind matches it up, matches the sensory packet to the information and current consciousness, and I retrieve the symbol of Tawny. Hey, there's Tawny. So we see this is the mind is noticing when there's a certain degree of similarity between the sensory packet and sensory information. And when it does, when there's enough similarity, it will retrieve that sensory packet in the symbol. You know, something that looks really close to Tawny, maybe it is Tawny, comes into my sensory current consciousness. My mind notices this, that there's a match between this and this sensory packet of Tawny, and I will retrieve this and retrieve the symbol of Tawny. So it's like this is a way for, you know, the brain to respond to what's happening in consciousness. You know, we're not just, the consciousness isn't just passively happening. It's just like, oh, there's Tawny, nothing happens. It's more like, oh, ding, 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 something matches. What is it? Oh, it looks like it's Tawny. Retrieve. You know, so it's like it's interacting with its own, with its consciousness. Its memories are interacting with its consciousness via algorithms. Okay, so that's important to understand because upon retrieval, certain things happen. An algorithm happens. So Pavlov's dog example, where the dogs learn to retrieve salivation in response to a bell. There's this sensory packet of food, the sight, sound, and smell of it. And it has a set of motor/glandular actions associated to it. So when the consciousness of dog contains sensory information that represents food, so a dog senses food, the mind will notice that this sensory information of food is similar to a sensory packet, you know, the food. And it retrieves its associated motor/glandular actions. It will run up to the food if it can't. If it can't run up to the food, then it might start salivating. Well, it'll just start salivating regardless. But if it can't run up to the food, it'll start salivating regardless. So it senses food, senses that it matches to the food, and it starts retrieving motor actions and glandular actions so that it can interact with this thing that it sensed, this food. But in the case of the Pavlov's dog, we're making it so that an additional sensory information, in this case the sound of a bell, will do the same thing, and you're adding this to the sensory packets that will cause it to retrieve salivation. So you're making we'll get into it right here. So classical conditioning creates an additional sensory packet that can elicit that same retrieval of that action memory. We'll just call it action memory. It may not be motor action, it may be glandular, just action memories. Put a hole in my wall. Yeah, doing a little too hard there. Okay, so this would then make it so that the sensory packet of a bell can now retrieve the salivation action, not just the sight and smell of food. Just the sensory packet allows it to retrieve the same memories. Algorithm. Okay, here's the algorithm. Check if SI, sensory information, reaches a threshold of similarity to any sensory packet. So we have all these kind of sensory packets that are in the mind, and the mind is constantly checking if any sensory information is matching to these sensory packets or is a certain degree of similarity. If it does, Well, that's the if yes, if this first step of the algorithm is a yes, well then we carry on to the next step. Oh, well, first of all, and the function of that first step is to retrieve memories. That function of that first step is to retrieve memories and operate on the what is sensed. Food, in that case. So I'll give you an example. I hope I'm not overdoing this here. But okay, so the example of this step, the smell of food is matching up to a sensory packet of food. And the mind notices that. And that has the information of smell. So then it retrieves. Oh well, then that's the next step. Okay, it sees that it matches up. So if the next step is retrieve the action memory, so it notices a match, and the next step is to retrieve the action memory, whether it be a glandular response or a motor action response, and retrieve that salivation. So see here, smell of food. The mind notices that this smell of food matches to a sensory packet. So then what does it do? It retrieves the motor action. That's the action memory, glandular or motor. It retrieves that action memory and behaves. Okay. Now, here's where it gets a little bit weird, a bit tricky here. So then it checks. So after it retrieves, this is in the same step. So the step is retrieve the motor action of the sensory packet and check if an SI, sensory information, and check if an sensory information that was present during the last retrieval of the motor action was present this time. So this is and also I've put in quotation marks P if you're reading this, and I hope you are, because it makes it a little bit easier. And that's for me to remind me to point. But anyway, the function of this step is it's identifying reoccurring sensory information when there is a retrieval. So it's seeing if last time this happened, was there a bell last time? Was there a bell last time when the last time it smelled food? So it's noticing consistent pairing of the ringing of the bell with the sensory information, with the retrieval of glandular responsive salivation. So every time there's the smell of food, there's also this ringing bell. So the last time, it's noticing that when the last time it smelled food, there was a bell. And there's this one, then this time there is two. And maybe the one before that too. And eventually it learns this algorithm. So I'll repeat this step again. Retrieve the motor action and check, this is the important step right here, or what I'm talking about now, and check if a sensory information that was present during the last retrievals of the motor action was present this time. So it's checking if the last time it did this whole thing, where it retrieved the salivation in response to the smell of food, if there was a bell then, if there was that same SI, whether it be a bell or whatever, flash of light, whatever, it's noticing that same sensory information is what was present during the last retrieval. Okay. So if there is a reoccurring sensory information upon the retrieval, then the algorithm makes that sensory information into a sensory packet. So right here, so it makes that bell that it noticed that was reoccurring and makes it into a sensory packet and attaches it to the MA. So that's added. So you have kind of these, I forgot to mention, these kind of base genetic sensory packets like food and the smell of it and stuff that you can't really unlearn. It's really hard to unlearn those. But then you have these kind of added on associated learned memories, which can go extinct, as I'll go into a moment. But this is an added sensory packet. So now, when something happens in here, a sound of a bell, since of this added SP, it'll match it to this. So whenever the SP, the bell happens, the brain notices that there's a match. There's a match that wasn't there before. There was no match before, but since the brain's previous, through the algorithm, added an SP, a sensory packet of the bell, and added it and it associated it to the salivation. So now it notices that there's a match, and it'll retrieve the salivation. Okay. So basically, classical conditioning is creating additional sensory packets onto existing action memories, motor glandular action memories. And then it allows the brain to retrieve these motor glandular action memories in response to these new added sensory packets, such as a bell. Operant conditioning. Operant conditioning creates entirely new motor actions and new sensory packets. So it's not just adding a sensory packet onto existing MA. It's creating entirely new motor actions and entirely new sensory packets to be able to operate within the environment. I'll use, because it does this with reinforcement and punishment memories. I'll use P and R as shorthand for punishing and reinforcing emotions. So back to that first step of is there a certain degree of similarity between a sensory information and a sensory packet? And if yes, retrieve it. That was the first step, if you remember. Back to that. Well, if that's a no, then we go to operant conditioning. Okay, so the first step of that side is check if a reinforcement emotion is perceived before, near, or after SI. So it checks if the first step is check if SI matches to a sensory packet. No. Well, check if there's a reinforcement emotion before, near, or after that experienced SI. So it's basically identifying if there was a reinforcement emotional memory perceived recently. Check what. So if that's yes, if that step is yes, if there was an emotional, reinforcing emotional memory, the next step is check what proprioception, sensory information, preceded the reinforcement emotion. And make it into an MA. Labeled as MAY. Check which sensory information wasn't in the preceding short-term memory. Make it into SPZ, sensory packet Z. Bond sensory packet Z and MA, motor action, MGA, motor glandular action Y, and make it active. So, okay. So what's going on here? Okay, for the part of the step, check what proprioception SI preceded reinforcement emotion and make it into in a motor action, labeled as MAY. So this is creating a motor action memory out of the horse. Here. Proprioception is basically the sensing of your own body movement, where it's going. So you can actually make, it would seem, motor actions. Your body can sense your own motions and make motor actions out of them. Okay, so proprioception is key to the operant conditioning. It has to be able to sense what its body's doing in order to make a motor action out of it. So we're checking what proprioception, what they're moving. So what it was doing, basically what it was doing when the reinforcement happened. So this reinforcement happens, and the animal needs to know what it was doing when this reinforcement happened. And make a motor action out of it, because it needs to repeat that. It needs to repeat that motor action so it can get the reinforcement again. That's why it's labeled as active. So there's these in operant conditioning. There's active motor actions and inactive motor actions, meaning there's an avoidance motor actions where I want to go do this and pursue this, and there's this more avoidance motor action like I do not want to do that again. That shocked me, and that depends on operant conditioning can go 4 ways. Okay, you can either have a reinforcement added, or you can have a reinforcement which is reinforcing and makes you pursue that, or you can have a reinforcement subtracted away. You have your food taken away. I don't want to do that again. That avoids. Now you also have punishment that is added, and you avoid those. I got shocked, crap, and then you have also punishment being subtracted. Oh wow, I stopped being shocked. I need to do that again. So I'm going to pursue what gives me reinforcement, what adds reinforcement, and what subtracts punishment. And I'm going to avoid what adds punishment and subtracts reinforcement. So we'll go over this again. So we check what proprioception, sensory information, preceded the reinforcement emotion. So, and make that into a motor action. Label that motor action as Y. So it's checking what it was doing when it got the reinforcement, and labeling and making it into a motor action, and labeling it so that the algorithm can operate on it. Now it also checks which SI wasn't in the preceding short-term memory. Now this is a little bit weird step. Check which SI wasn't in the preceding short-term memory. So it's noticing patterns here. There's this pattern of short-term memory. There's a breeze going. We feel the breeze. F. That's the same breeze. There's grass. And the short-term memory makes it notice so that it's the same. The current consciousness is the same as the short-term memory of the past consciousness. It's all the same, and the horse in the field, except there's something that disturbs it. There's something that's different, and that wasn't there before. And all of a sudden, for example, you call the horse or whistle at the horse, and all of a sudden it's different. Hey, this wasn't here before. This is different than what's happening, and it notices this difference. And it notices that stimuli and makes it into a sensory packet. So it makes that sensory packet into sensory packet Z. So, for example, a horse comes to you after a call, and if you shake your oats around and you call after him, and you reinforce them with oats, the horse learns to come to you to call after. Learns to come to at the call because it's being reinforced with food. So it makes, the motor, its proprioception of walking towards you is made into a motor action, and the call of the whistle is made into a sensory packet, and so those two are bonded together. So now when the horse hears the whistle, it will retrieve its motor action of walking towards you. So and that's a completely new thing it didn't do. It's walking towards you at the sound. It has this motor action. It's retrieving at the sound of a whistle, which I can't really do. I can't really whistle very well. But okay. So if the step that we were just on is no, let's say if that the first step of the operant condition, is there a positive reinforcement being added, or is there a reinforcement emotion being added? Then it goes to the other one, which is a punishing emotion near or afterwards, and basically does the same thing, except the opposite. It just has the same step, except for it makes it avoid instead of pursue. And that motor action. And that I don't really want to go through all that. But yeah, you get the pretty general idea, I hope, is that classical conditioning is just adding on sensory packets, whereas operant conditioning is creating entirely new motor actions and sensory packets. And it's doing this through algorithms. Now, extinction, these created memories, if not retrieved for extended periods of time, the memories will be will start to lose their association and fade. When these bonds between these memories start to fade, but it seems the memories still stay there because you can learn them faster again. So it's like the memory stays. It's just this association between them fades, and if it's not retrieved enough. So, for example, a horse learning through operant conditioning with a horse with an electric fence. A horse shocks itself. It learns through operant conditioning to avoid that motor action. And but if you turn the fence off for a while, that's why they'll eventually get back out, because they forget. They're associated. Their memories does kind of, that association disappears. That memory, that behavior goes extinct. So you kind of have to leave it on. For horses. Okay, my therapy from this perspective. So, how first of all, we'll go into how my theory relates to other theories of psychology. So, you have personality psychology, which is these kind of different, I would say, states of memory systems. You have these different memory systems, and they're in a different state, which then causes different behavioral patterns and different personalities we see. Sigmund Freud, ego, superego, id. kind of have these base emotions, which are you're operating off of, which is kind of the id, and then you learn over time the new memories, which kind of operate as your kind of like super ego. And yeah, I don't want to get into all that. But you have this idea that we're all kind of just, we're not like super, we're not like, humans aren't super cognitive, like cerebral beings. We love them, but they're very instinctual. They're very emotional. They're operating off of these memory systems, and they're very much like enslaved by them. They just can't get out of them, and that's very something Freudian. But they can think about them and grow them and get out of them over thousands of years. These memory systems. So experiment. So what evidence would I have to support this type of mind model? Well, in psychology, we test theories largely through prediction and modification. We see if the model in question consistently predicts behavior or modifies it. And this model definitely predicts behavior. If you tell me you love a sensory packet, such as your mom or dad or sister, then you'll care for her or him and want to be around them. Or if someone is prejudiced towards a certain sensory packet, then they will not behave very well towards them. And also, forgot to mention these goals. You have goals over here. I don't know why I didn't. Where was that at? Did I miss that? But anyway, you have goals which are associated to that, and your emotions create these goals often. And if you have unhealthy emotions associated to sensory packet, then you're going to have a set of unhealthy goals, and those goals are critical in predicting behaviors. And our symbolic memories affect our predictions of reality and how to go about solving them. So the belief system, if we can judge someone's belief system, we can predict their behavior. If we know their emotional associations to their sensory packets, we can know their goals and therefore their behavior. If we know their belief or their belief network, we can more predict how they're going to behave towards it. But the big thing here for me is modifying these memories. It's essential to my therapy. Rationality therapy is about rationalizing this memory system, evolving its symbolic perceptions, its belief network, the past, present, future, and probably most importantly, its emotional associations to the sensory packets that it has. So what we in turn will modify the output, the behavior. You're trying to change the state of the memory system to modify the behavior. Okay. So what we believe about the sensory packet and how we feel about the sensory packet determines how we behave towards the system of reality outside that this sensory packet represents. We have to modify these emotional and symbolic memory associations to modify behavior. All right.